Hi there, my name is David Reside, and this is Developing Carbon Stories, a podcast about the project developers creating the most innovative and impactful carbon projects in the world. Developing Carbon Stories is a project by Abatable, a carbon intelligence and procurement platform that helps companies purchase high-quality carbon offsets. Each episode, I speak with an entrepreneur from a different part of the carbon ecosystem and talk about their journey so far and how they are acting on climate change. On today's episode, I'm speaking with Gonzalo Fuenzalida, the CEO and co-founder of Andes. Andes is developing biotechnology solutions which can increase agricultural outputs or sequester carbon for thousands of years. We dive into how it works, who can use it, and why it could become a much bigger tool for climate action in the years to come. Gonzalo, thanks so much for joining me on today's episode of Developing Carbon Stories.
Absolutely, David. Happy to be here. Thank you for inviting me.
I'd like to start by talking about how you got into the business of climate action. Just doing some low-key snooping on your LinkedIn page. I saw that you have a background in finance. You founded two other companies before Andes in, I guess you'd call it pharmaceuticals and biosciences space. Can you talk about that journey and how it led to Andes?
Yeah, sure. As you mentioned, I started my career working on investment banking. My background is on business administration and economics. I always love markets, and while working on investment banking, I learned a lot of great things. I have the possibility to work with great people and got a lot of responsibility very young. And I started developing a career there, David, which was very well paid, but I honestly was a very unhappy person. Up to the level that my Sundays suck because I was thinking on the markets on Monday and everything, right? So and not everything is money. And I think for me, that became very clear when my first son was born. This sounds cliche, but I guess when I was younger, before having my first son, I had a list of things that I thought that were important to obtain in life, and many of these things on this list were material things. But then when you see the miracle of a new person joining the world, I mean, a click inside of me just triggered, and this list of things that I thought that were important, I just trashed it, and a new list populated that had to do with a lot of things that didn't involve a direct benefit for me. And I guess this is how nature and we humans right work. So yeah, I've always been in love with nature since I have a memory. I remember my sisters making laugh of me, calling me Mr. Nature, because I could be staring into a couple of trees for an hour, literally.
Wow.
I've always been fascinated by this natural, everything in natural, right? So I always wanted to work on something related with science. I knew that from very young, but circumstances made me took the path of studying on investment banking. Now, I had a luck, and while working on the banking industry and my first son being very young, I started a first biotechnology company. I am originally from Chile, from Santiago, born and raised in Santiago. I was lucky enough to be able to work at the bank. I was working at that time, and at the same time in the afternoon studying my company, and that company was successful. After a year or so, we did an acquisition of another biotechnology company here in California. Now we're based in Northern California. And that's where my connection with the United States and California started. So yeah, a few years after, I remember having a beer with a good friend of mine, a renowned scientist, Bernardo Gonzalez from Chile. Bernardo has been studying interaction between bacteria and plants for, I don't know, about 20 years now, 25 years now. And I remember in that conversation, he telling me about how bacteria interacting with plants could have beautiful outcomes that could transform agricultural industry for good, They could enable the replacement of chemicals. That they could make all the process of growing food more clean and sustainable. And David, I was naive at that point of thinking that it was easy to create a product from scratch from bacteria and convert it into something a blockbuster and push it into the agricultural industry. But yeah, I guess from the very beginning, we understood which were the biggest challenges, and we were lucky to be able to bring a great team, including the co-founder of Andis, Tanya Timmerman, who is a scientist also studying interaction between bacteria and plants for a very long time. So yeah, that's how in a very short how Andis started and how my career developed from being a sad person, very successful economically speaking, but sad person, into a person that is happy and my Sundays are beautiful now. I love what I do.
Yeah, it sounds like an amazing journey, especially going even further back to being teased for being nature boy, and having that as well to come with you is an amazing journey. And so, I mean, Andy's has been around for, is it a bit over 6 years now? Is that right? And it's got, again, this is just off LinkedIn, but with over 50 employees now?
We are 30 full-time employees.
30 full-time, yeah. And so, can you walk us through those, that 6-year journey and how you've gotten to where you are?
Sure.
Sure.
Yeah, it's been a journey with highs and lows, David. The first 2 years developing Andis were very cool and very fun. So one of the first things we did was collecting soil samples and plant samples, and in order to isolate microorganisms, specifically bacteria. So we travel everywhere through the Americas, from northern states here in the United States down to the south of Chile. We even have a collection coming from the Antarctica. So basically what we did, David, is that we went to very extreme environments where either agriculture was being performed, or where you could see plants thriving on very harsh environments. And what we did was looking into those roots of those plants and extract and characterize microbes. And this is important because when thinking on developing a product based on a microbe, you basically, our vision is being able to use these natural microbes, but also engineer them. So when you think about engineering them, you think of them as chassis, and the most robust the chassis, the better. So that's the reason why we started this process of collecting from these very extreme environments. And that took us about 2 years. And after that, at that point, we were based in Santiago, in Chile. At the same time, in parallel, we developed a way in order to deliver these microbes on an efficient and effective way. And what we developed for that is a proprietary seed treatment by which basically we load inside of the seeds the bacteria of interest. So as a final product, we can have a seed containing the bacteria of interest that performs very well on a specific trait. So that way we can guarantee that every single plant on a field on, say, North Dakota or Illinois or Santa Fe in Argentina, it can be performing and interacting with the bacteria of interest very well. So that was the beginning of the company. That was what I call the first chapter. And the second chapter was basically moving here to the United States. We got to a point where we needed to money in order to fund our research and development activities. We needed the talent with enough experience to start working with the bacteria and doing these processes of engineering and making them better. And third but not least, we wanted to start partnering with incumbents on the industries that were relevant for our first application, which is agriculture. And unfortunately, all these three elements are difficult to find and obtain in Chile and in South America in general. So that's the reason why we moved here to the United States in order to bring a world-class team scientists that could help us develop the products, to bring investors that could fund our activities, and also to start a collaboration and partnering with relevant incumbents of the agricultural industry. And fortunately, we were successful on doing these three things. So yeah, that's the second chapter. And for these 6 years, David, it has been all. I mean, the two first years were very fun because we traveled a lot and we collected all this from these incredible places. But then it has been only research and development. And now, for the first time, we have a first product that comes from the technology for carbon capture, which is the offsets that we generate, right? So it's a very nice. This is chapter 3. We started chapter 3 on the company where we start offering a product and starting revenue, which is great. So yeah, that's it. That's in a brief.
Yeah, sure. Well, let's talk a little bit about the product itself. So it's a seed treatment, but I guess sort of the traditional seed treatment is seed coating or other even scarifications or something to seeds. But how is what you're doing different to that? Because it's sort of imbuing this bacteria to the inside of the seed. Is that correct?
Yes. And it's different because although coating has been the coating of a seed, that means putting for example, the bacteria on the outside of the seed, is something that has been done for the last 20, 25 years. But the problem with that delivery method, David, is that you cannot guarantee the performance of the bacteria. And typically, when performing coating, you will see a settlement. That means that the percentage of the bacteria that will be actually interacting with the plants, the settlement typically is in the range of 60%, 50 to 60%. And that is not enough in order to compete with a chemical input, right? Chemical inputs are great because you can trust that they will work as intended and are very efficient, and the efficacy is very high, right? So in order to have a new technology to transform an industry such as agriculture, you need a delivery method that can guarantee that every single plant will be interacting with the biological you're putting there, right? And that's what we're bringing into the market. For the first time, with our technology, a farmer can trust that a biological will replace a chemical input because we can guarantee that microbe will be interacting with the plant, right? Our settlement rate is close to 100%, which is what you will find from a chemical product, right? So that's a big difference.
Okay, so this so the bacteria as it's engaging with the environment around it underneath the soil, what's it actually doing there? What is it actually doing to help promote beneficial agricultural practices and also sequester carbon?
Yeah, sure. So we are currently focused, Davis, on two distinctive different programs. Mm-hmm. The first program is focused on what we call biological nitrogen, which is basically a nitrogen that is captured by the bacteria, and the bacteria can transform that nitrogen into a form that the plant can uptake. Nitrogen is, in the case of corn, one of the most important fertilizers, nutrients that the plants needs to grow, right? There was nitrogen is great and transform agriculture and the way we produce food. This is funny because before two German scientists discovering a way of capturing nitrogen from the earth, Chile, my country of origin, was the biggest producer and exporter of nitrogen. Mm. And after these scientists, their last names is Harber and Bost, discovered this way of capturing nitrogen from the earth. Basically, they were able to produce cheap nitrogen, and our country went into default because of that. And we have to start all over as a country because we depended very much on this product. So yeah, these scientists discovered a way of picking nitrogen from the air and converting it to a form that you could transform into a product that then farmers could apply on the field. If you could look into the molecules that are in the air that surround us, roughly 80% is nitrogen. And it's on a form that basically the plants cannot uptake. So there are basically, naturally, there are two ways that this nitrogen transforms into a way for the plants to be able to grow. One is through lighting. Anytime you're looking into a storm and you see a lighting happening, that energy has the ability to break up this nitrogen and transform it into a form that then falls with the rain and the plants can uptake. So when you're seeing a storm and lighting, that's life. That's nitrogen that is coming into the world and the plants can feed from that. And there's another natural way for this atmospheric nitrogen to be captured, which are bacteria, right? And that's a strategy that we are exploring here and this with this program. We engineer bacteria for them to be able to grow with corn on the root structure, and while doing so, they are grabbing atmospheric nitrogen and converting it into a form that the plant can uptake. Now, this is not easy. This is tricky because the bacteria that have the ability to fix atmospheric nitrogen, typically these bacteria will fix nitrogen while they are on an environment without nitrogen. And on a farm, you will have nitrogen on the field, right? And it makes sense. Why the bacteria will be continue fixing nitrogen if it already is encountering a lot of nitrogen on the field, right? So in order for enabling that, we need to modify the bacteria in order to unlock their capability and for them to be constantly fixing nitrogen. And the idea of this strategy, David, is to be able to replace synthetic nitrogen for biological nitrogen given by these bacteria. Why we are trying to replace synthetic nitrogen, you would ask? Because it's a big contributor to global greenhouse gases. Synthetic nitrogen production and use represents roughly a little bit over 3% of total greenhouse gases emissions in the world. So if we find a way of replacing that, we could start making a huge dent on that contributor to global warming, right? So that's our first program, nitrogen. Now, the second program, it's focused on carbon, and these are different types of bacteria that are working different to how the nitrogen bacteria works. The strategy that we are pursuing for the carbon program is that working and using bacteria which have the ability to produce inorganic compounds in the soil while growing with the plant. So if you could look into an hectare or an acre of corn during a season, basically there's a huge amount of CO2 that the plants in that cornfield will be absorbing from the atmosphere because of the process of photosynthesis. And depending on where you are sitting on the United States on the Corn Belt, that number could be from 90 tons of CO2 being captured through photosynthesis up to 140, 150 tons of CO2 when you are on places where you have higher yields of corn, such as the Iowa, Illinois, or Indiana states. The amount of capture that is happening because of these plants is brutal, and the amount of flux that is happening there of CO2 is huge. And part of this carbon that is absorbed by the plants will go into the biomass of the plant. And another important piece will be brought back to the atmosphere through processes of respiration that the plants do, and also soil respiration that typically happens. So if you could look into the root structure of a corn plant during a corn season, you will see a lot of flux of CO2 that at some point is releases back to the atmosphere. So it's a good idea to put a biological tool in that specific place during that specific moment, fixing these CO2 molecules and converting to something that can lock the carbon for a very long time. And these molecules that these bacteria produce are typically bicarbonate and also carbonate minerals, such as calcium carbonate. This is a strategy that is quite different to what has been done in agriculture in regards to carbon programs. Typically, I don't know if, David, if you are familiar with regenerative agriculture. So regenerative agriculture is if you ask 10 people, you will have 10 different answers. But the consensus is that farmers can do change of practices in order to build up organic matter on their soil. And by doing that, they will be locking carbon, not for the long term, but for a few decades, right? Our strategy is quite different because we are not focused on organic matter buildup in order to create carbon capture and offsets. We're focused on these inorganic compounds that are contrary to organic matter. These inorganic compounds, you can guarantee their stability for thousands of years. And that characteristic, it is referred as a high permanence approach for carbon capture. And it is something that is desired by buyers of carbon offsets and carbon credits. the higher the amount of time you can guarantee that carbon will stay captured, the bigger the value this carbon offset has for buyers. And it makes sense, right? We don't want to lock carbon for only 10 or 20 years or 100 years. We want to lock that carbon for thousands of years. And that is our approach. So yeah, we've been conducting field trials for the last 3 years now. Data coming from this season looks beautiful. We are in the verge, David, of communicating and showcasing a tool that could truly tackle climate change at a scale of gigatons. So I feel very lucky. I feel very proud of what the team here has developed. We're studying deploying a technology that will be one of the key tools in order to combat climate change. So yeah.
Yeah, and I suppose it has lots of other potential benefits as well, like you were talking about, in terms of improving agricultural performance. Now, obviously, the first product you mentioned, doing that through producing nitrogen, in that natural process. I'd be interested to hear about the impact that the second product can have on agricultural performance. Like, is there any difference that you can engender by using the product which is actually maximizing inorganic carbon in the soil?
So your question, David, is if we have co-benefits of performing that capture?
Yeah, exactly.
Yeah, we do. So the bacteria we're working with for the carbon program, besides being very good on producing these inorganic compounds, there are also two traits that these bacteria have that have a direct effect on the health of the plant and the yield. One of the traits is that this bacteria has the ability to produce a hormone that is called indolacetic acid. It is part of the auxins molecules. And basically, this plant hormone has the ability to increase the root structure of the plant. And it makes sense, right? Some bacteria has the ability to induce this bigger root structure. The bacteria will want to be interacting with a plant that is biggest as possible because the bacteria gets a lot of nutrients from the plant, right? So this bacteria has the ability to affect the development of the root structure, and the bigger the root structure, the bigger the flux of CO2, the bigger the intake of nutrients by the plant, and thus the bigger the better the health of the plant and the bigger the yields. We've during these 3 years of field trials, we've been also measuring yield performance, and what we've seen in corn is that we can increase basically 5 to 6 bushels per acre. If you translate that into dollars for a farmer, we're talking about anywhere between 20 and 25 extra dollars per acre for a farmer, which is great. In the case of soybean, the performance looks like closer to 1 extra bushel per acre because of this bacteria having an effect on these plants. So yeah, there's a positive co-benefit of using this technology by farmers, right? They are not only capturing a lot of carbon in this inorganic form, but they are also experiencing better, healthier plants and bigger yields. So yeah.
Yeah, sure. And so it sounds like you've been doing a lot of testing on corn. How many species can Andes do its treatment on?
Oh yeah, that's a good question, David. And we started at the very beginning of Andes working with lettuce, and I don't know why. I don't know if you've seen a lettuce seed. They're minuscule,
tiny,
so small, so it's so difficult to work with. But we managed to load the bacteria inside of these very small seeds. And but after so we work on many kinds of seed, and that includes lettuce, tomato, and then at some point we understood that if we want to create a huge impact on the environment and on people, we needed to jump into row crops, crops that are extensively produced across the world, and that's where we jump into corn. Corn here in the United States is king in regards of acres, in regard of money that subsector of agriculture moves, right? So it was a good idea to focus on corn. We're working on soybean as well. This year we started working with wheat and also with sunflower. Our plan is also including other intensive crops such as canola, barley, and rice in the near future. So basically, with these 5 or 6 intensive crops, we will be covering a big chunk of the land that as a humanity we use to grow food, right? So yeah, yeah.
Yeah, so I mean, I guess the technology sort of it lends itself to annual crops. I mean, do you see a possibility in the future of maybe being able to use it for perennial crops, or even, you know, like a natural reforestation, you know, with tree species potentially? Yeah, is that something that's in the future of Andes?
Yes, David. In fact, that is something that we are looking into now. Forests bring a challenge for our strategy. Typically, if you look into the soils of forests, that pH will be relatively low. And what happens with inorganic carbon compounds with a low pH is that typically these minerals will either break up, or if you are working with or generating bicarbonate, it will convert into another form of dissolving organic carbon, which is carbonic acid. And carbonic acid is very unstable, right? So you don't want to lock carbon as a carbonic acid form. But yes, as we understand better the mode of action of the bacteria and how we can tweak those bacteria in order to make them better performing, it is part of our plan to explore perennial crops and also forest soils. Forests are especially interesting as a you know, a lot of offsets currently comes from forest related projects, right? So if we have the ability to those projects make them better in terms of generating more value in this form of offsets, I mean, that's something that we would like to see and explore. But yeah.
Yeah, absolutely. So, I mean, I think a massive challenge with you know, land use and land change projects, particularly in the carbon world, is this challenge of permanence. You know, people often look within a 100-year time horizon, and often with, you know, when people think of soil carbon, you know, they'll often think of really short permanence. And so being able to integrate a solution where you can actually have permanence for, you know, on a timeline of over 1,000 years would sort of revolutionize, or at least change perceptions of that that type of land use change carbon. And I guess I mean, it also brings up this question of you know, thinking from a global perspective on the conditions that are best for growing Andes seeds. Like, do they favor particular conditions, like in the US on the Corn Belt? You know, could they also be used in a more tropical or perhaps in more arid conditions? Yeah, are there any parameters around that?
Yeah, that's a good question, David. We did an extensive analysis on the soil in the United States, Canada, and some countries in South America. Basically, for our first generation technology, within the continental United States, there are roughly 200 million acres that are adequate for deploying the technology. If you look into Canada, we can add 44 more million acres. If we look into South America, and we are talking about parts of Brazil, Uruguay, Paraguay, and Argentina, we can add another 120 million acres for the first generation technology. So there's a lot of acreage for deploying our technology broadly. For the second generation technology that is coming next year, we will be able to further increase the land that is suitable and ideal for deploying this kind of technology. So yeah, we have a tool with that is very much compatible with what we have on hand, right?
Yeah, right. And so you're headquartered in Northern California. Where are you operating at the moment, and you know, who's using these products?
So we are based on the east side of the San Francisco Bay Area, on a city that is called Alameda. We moved recently to a new facility here in Alameda. Before, we still have our original facility in Emeryville, which was a warehouse, David. We we worked there a lot of years without natural light, so now it's great to have windows and yeah.
That's very startup of you, yeah, to be working in the
Yeah.
warehouse with no windows.
Oh
yeah.
Yeah, but it's part of the story, right? And it's part of the
Yeah.
cool. We only have good memories from that phase, right? So yeah, and but we are working basically this year we're focused on the United States. We deploy our technology on 27,000 acres this season. We're focused on several states on the Corn Belt. We're working on 200 different farms. So it's been fun. I guess what is very exciting, David, is that given the business model that we are proposal that we are offering farmers, we are seeing a big pull from them wanting to participate on the program. And this is very important because when you look into traditional agricultural carbon programs, there's always a big challenge of enrolling more farmers, because for those traditional programs, the programs ask farmers to do change of practices, which means that they have to spend money and time in order to do that with an uncertain return, right? So what we offer, Andy, is that the farmers don't need to do change of practices. They only need to start using our microbial technology on their fields. And that technology is provided on a way that is seamless, integrated into their processes, so they don't have to do any big changes in order to participate on the program. They don't have to spend money, they don't have to spend time, and they get a payment at the end of the year that is a guarantee no matter what, and they get the extra benefit of extra yields on the farm. So, and this is important, David, because when you think about the strategy and what we want to accomplish, we want to create this huge impact understood by millions of tons of carbon being captured every season. So you need to have a business model that is aligned with the current practices from the farmers and not have friction when thinking about jumping into 1 million acres or 10 or 50, right? And we've found a way in order for that to happen. And that is a key aspect of, it's not only the technology working, but it's also our partners, in this case, the farmers, being with the aligned incentives in order for this to work and grow exponentially.
Yeah, sure. So I guess the ease of integration is a real selling point. Are there any potential downsides? Are there any risks to using this bacteria and really generating all those I guess nitrogen in that fashion or bicarbonates? How does are there any risks in that space?
Yeah, that's a good question, and in part is the first question a new farmer asks, right? So for these 27,000 acres that we are covering this season, roughly 80% of the farmer participating on this program this year already did field trials last season with us, so they could see on their fields better yields, healthier plants. And the benefit that our technology provides, and that was important for them to jump into this year to commit more acres. So yeah, in agriculture, it's very important when you are offering a new technology or a new product to have data to support that you won't have a negative effect on the yields or the performance of your. And we have that. We have 3 years of extensive field trials, and by extensive, we're talking about thousands of acres that we've deployed technology from North Dakota down to Ohio. So covering all the Corn Belt, different hybrids in corn, different hybrids in soybean. So we have a plenty of data showing the good performance of our technology. That is important, and that is a good question. Yeah.
Yeah, I mean, with all these upsides and relatively low risk, do you have any sense of whether Andes could be used to improve livelihoods in developing countries potentially? Like, is there a role that this technology could play for smallholder farmers?
Yeah. We during our last funding round last year, we brought into the company as investor and partners Bayer, the German company Bayer. And Bayer is one of the two big incumbents on corn seed and soybean seeds around the world, and other seeds around the world, right? All together with Corteva. Syngenta is another player, but Bayer and Corteva are the biggest ones. What was appealing and attractive of bringing an incumbent like Bayer is thinking in the future on how we want to deploy the technology. Deploying the technology here in the United States through the Midwest is something that we could easily do ourselves. But when you think about global scale, you will need a partner like a Bayer, right? A company that has operations on every single continent and have access to countries that are under development. When we started the company with Tanya, the other co-founder, that was one of the things that we said that we will take care of. We don't want just to make a huge amount of money on the United States or developed countries, but we want this technology to be able to reach also those that are not that fortunate, right? And the strategy of developing, delivering the technology through the seed is compatible with that idea, right, David? A unit, a bag of seeds can be with the strategy that we're pursuing for delivery, the microprime seed treatment method. It adds stability to the microbial technology, and that bag of seeds could reach any place in the world, right? So the farmer can start using that seed that brings either the nitrogen fixation or the carbon technology, and they can get benefits from participating on the program and while helping contributing towards fighting climate change. So yeah, that is part of our vision of delivering through the seed. You can reach any corner in the world, right? If you have a technology that is stable and can be delivered through the seed. Yeah.
Yeah, I mean, that's a good little, I guess, segue into the voluntary carbon market. Abatable has listed Andes on our online marketplace, as a project of high quality, a carbon project. But how else is Andes engaging with currently or looking to engage with carbon finance?
Yeah, so we're just in the process of, we were under the radar for a long time, David, while we were working on the research and development part of our carbon technology. Our first patent became publicly available, basically showcasing our strategy and how we're performing all this carbon capture. So now, and also we started this season our first commercial pilot, right, covering 27,000 acres. So we're in that process of engaging with big corporations in order to start offering our carbon offsets, and we will be doing announcements very soon. So yeah, it's great to be in this moment, starting a third chapter where we have our first product and we are starting the offerings. If everything goes right and everything indicates that we will get to this point very soon, in a few months we will be announcing that a huge amount of carbon that our technology capture in the form of high permanence carbon capture, and that will position David Andes as the biggest project developer creating high permanence carbon credits in the world, and that is fascinating. For the first time, there is a technology that is scalable and that can offer a high permanence carbon offset at a price that is similar to what you've seen from forestry projects, which is unseen, right? It is a new category of offset that brings this high permanence characteristic into the market. Our targets and our dreams of growing are very bold. We wanna get into gigaton scale by 2030. And we think we're well positioned in order to do that as we engineer the strain to make it perform better, and as we are able to deploy broadly across millions of acres this technology. There's a high chance that we will be successful on reaching that point very soon. And again, with high permanence carbon offsets, right? That is probably what we want, or the ideal, right? I'm not saying that you shouldn't explore carbon from avoidance or low permanence. It's just that today we don't have high permanence at the volume that is required, right? And that's what Andes is bringing into the market.
Yeah, and there's a massive demand for it as well. I mentioned this on a previous episode. that we did about the Frontier Initiative, which is a whole bunch of companies, led by Meta and Stripe, and a couple of other large players as well, pledging almost $1 billion, looking for high permanence carbon sequestration solutions. So I mean, being able to scale and being able to deliver this solution is critical, but also having the demand side being there means the potential for growing this is simply, it's enormous.
The Frontier Initiative that is led by Stripe is it's admirable, and hopefully we'll see more initiatives like that one happening. That is what we need, right? It's putting a group of big potential buyers together and align on what they need to buy and what they need to do, right? Jump into action. So
and I guess knowing that we've got all these products coming through, we're in chapter 3, as you put it. What's chapter 4 and chapter 5 looking like? What do the next few years have in store?
So that's a good question, David. This connects with our long-term vision, right? Let me go a little bit back. If you could think about the history, not written, by the history of our planet. Basically, Earth is 4.5 billion years old, and for a lot of for billions of years, this planet was a planet that cannot sustain life because of the characteristics it had. It didn't have oxygen on the atmosphere, and at some point there was an atmosphere that was saturated with CO2. And one of the first living organisms that start thriving under these very harsh conditions were microorganisms, bacteria. And it is thought and understood that bacteria had a great role into shaping the world as we know it right now. We know that they had a great role on shaping plants and animals and humans as well. We as humans interact with bacteria. We develop as a species with bacteria helping us. So the same is true for plants and the whole world, right? So our vision is being able to use these biological tools in order to fix what we've broken. And that's we use the slogan of empowering biology in order to fight climate change, and that's basically our vision, right? We like the concept and the idea of relying on microbes, leverage in these first applications on agricultural practices in order to be able to fix our world. Now, fourth chapter is a little bit crazy, and we have some besides these 2 programs. There's a 3rd program coming, and I cannot disclose much, David. It is a little bit of a science fiction, but we are building the data in order to be able to sustain our claims on what's coming. But it's basically also the use of microorganisms. In this case, they will be engineered microorganisms, leverage on other industries, not related with soil, that will have the ability to sequester abundant carbon and logging it into a permanent form, while at the same time producing other products of high value. So that's chapter 4. It's thinking of this as a platform with new programs that will be tackling other industries while generating a huge impact on the environment and people.
Wow, that's a very interesting but also partly guarded response. So absolutely fascinating. I mean, I guess we're sort of coming up on time, and there's lots that I'd like to keep asking you about. But if we could finish on one thing, I'd like to hear what you're most excited about. In the tech space that you're in, like the other players that you talk to and you collaborate with, what do you find most exciting outside of what Andes is doing, of course?
In regards of of everything, David, or technology, or I guess one
Could be
thing that
anything.
excites me.
Yeah, something that
Yeah,
excites. Yeah.
I think one thing that excites me very much is that we are all studying, everyone that is working towards fighting climate change one way or another. We're starting to see a lot of momentum for different reasons, from governments, from companies, from consumers, which is the most important piece, right? If you look into younger generations, when you ask them about what are their concerns, climate change is top of mind, and I love seeing that. That is not something that my generation has on top of mind. So I have this a good feeling that what's coming. I mean, we're facing a huge challenge, David, that will impact every single one of the human beings on Earth. But we are seeing all these technologies and investors and companies and consumers aligning on this idea that we need to act now, and we need to act fast. And that is a really when I did a change in my life towards working on things that could basically benefit others once I'm not here in the world. Having that momentum and seeing and being part of that wave, I love that feeling. Makes me feel good about the future, about the future.
Yeah, that's what a fantastic way to wrap up. A message about unity, about inspiration, about global change. Yeah, it's just been great hearing from you, Gonzalo. So thanks so much for joining on today's episode. I'm really looking forward to seeing what Andes does in chapter 3 and beyond.
And beyond, yeah, a pleasure being here, David. A pleasure meeting you, and thank you for inviting me. Yeah,
of course. Thanks, Gonzalo.